Please welcome Thomas Ribeiro, French National Centre for Scientific Research.
So hello everyone, my name is Thomas Ribeiro and I'm the head of the startup department at CNRS Innovation. CNRS Innovation is the National Technology Transfer Office of CNRS in France. And since 2019, we implement RISE, which is an entrepreneurship support program dedicated to deep tech researchers. This is through RISE that we had the chance to meet Melpomeni, so it was back in 2021. And at that time, we were already really impressed by our vision and our determination to make the society benefit from those groundbreaking results that she got during her PhD. So this is based on the research performed under the supervision of Marc Antonini. So I have to check my cheat note because I forgot the name of the lab, which is the Laboratoire d'Informatique Signaux et Systèmes. And PearCode aims to revolutionize the digital industry by providing a revolutionary solution for archiving digital data. And I will now leave the floor to Melpo, so she will introduce you to use the startup.
Breaking the wall of unsustainable data storage using DNA. Melpomeni, Dimopoulou, PearCode.
So every day we are using our smartphones and computer, generating an enormous amount of digital information. We are generating a data tsunami that keeps increasing and can no longer be tamed. But did you know that 70% of this information will be labeled as cold and remain inactively stored for long periods of time? So what do we do today to store this information? We are creating large data centers. So practically, we store this information into either hard drives or even tape, which suffer from a very low capacity and a very short lifespan of only 5 years. Actually, we need to migrate the data every 5 years, and this is very destructive for the environment, and also it puts the data's fate at stake. So what if we used DNA, nature's oldest information carrier, in order to archive digital data? 1 single gram of DNA can store as much information as an entire data center, while also offering a durability of thousands of years without loss of information. So it is a very eco-friendly alternative, as we are going to eliminate the need for migrations into data centers. So how it is done? Any digital information is expressed as a sequence of zeros and ones and can be encoded into a quaternary representation composed by the symbols A, C, T, and G, that are used to represent the building blocks of DNA. Then the encoded sequence can be synthesized into the form of synthetic DNA and stored into a storage memory. To retrieve the data from the memory, we're going to use some special machines that are called sequencers and can read DNA strands, and then we can decode the information to its original digital form. Concretely, at PearCode, we want to propose a fully automated random access DNA memory. And we will be selling it to any tech giants or data providers with high archiving needs. So we will be selling the product along with the necessary drivers and also subscriptions for the necessary consumables. We will also be offering the service of data management and also any maintenance services. At PearCode, we have a very strong know-how on information theory and more than 80 years of experience on the topic of DNA data storage. What we wish is to propose a solution which is going to be optimal in terms of coding costs, so the best coding quality at a minimum price and flexible to the needs of our clients. So today, our startup is a deep tech startup. Our fully automated product is at the low TRL level of TRL 4, but however, DNA data storage is already possible and available as a non-automated service at the TRL 7. And we can address with that some first niche markets, such as the product and traceability market, or for storing information about luxury goods and high-value data. So the main challenge remains to automatize the process and to be able to provide it at a larger scale in order to massively store digital data, to highly reduce the costs of energy of companies and also add the extra level of security to their data. Our team is still relatively small. However, it is composed by 4 very skilled profiles, and we will be hiring another 2 profiles by the end of the year. And we have already we have already won multiple innovation prizes and raised non-dilutive funds. Our goal is to raise another 2 million beginning of next year in order to propose a first solution for automated reading by 2027, and another 3 million at 2027 in order to be able to propose a fully automated read-write product by 2029. At PearCode, we believe that the future of data is not only about storage, it's about sustainability. It's about heading towards a greener future, because DNA data storage is not science fiction. And together, we can make this future a reality. Thank you.
Okay. So we don't take the question in French, no?
We can if you want, but I don't think that they will understand.
We can ask the jury. It will be, look at all these questions, only in French. 1, 2, 3, 4, 5, 6. Okay, in the row. Let's go with you, Iris.
Thanks for the presentation, super interesting. I was wondering if you could comment a little bit on the cost and the energy needs compared to current data centers.
Yes. So currently, the energy will be actually using the machines that we already use, but it will only be used for the purposes of writing and reading, which is going to be like once in a while. We are going to eliminate the energy cost for all the migrations that are happening during the archiving. So this is our goal right now. And secondly, the cost is relatively high for the moment. This is a topic that is not it's quite recent. So the cost for now, it is only used for small applications, such as biology or medical applications. But the goal is also to try to improve and to reduce this cost so that it's going to be applied at a larger scale.
Okay, thank you. Next question, please.
Thank you so much for the presentation. I'd be interested in the competitive landscape and what other methods or solutions are there to address this problem.
So actually, there is competition in Europe and also in the United States. There are many academic also consortiums that are being built. So there are also some startups that are being created. We are all at pretty much the same level of development. However, our head start is crucial. Right now, it's like everyone has their own solutions. They're complementary. And this is why we need alliances in order to push this further and to arrive to a solution the quickest possible, to an automatized solution the quickest possible.
Thank you. Rasmus, I see you, yeah.
Can you talk about the speed of reading and writing and also the error rates?
Yes, so the error rates are pretty much the same that we have in classical channels. It can happen during writing, but also reading. The thing is that we also have a process of redundancy. We create redundancy using PCR amplification. So actually, we can tackle errors as we do in conventional channels. It's pretty much the same thing. Regarding the speed, for now, it is relatively slow. And we need to increase also that. So one main challenge is also to be able to make it faster, not only to reduce the cost, but the second challenge, which is important, is to read faster and write faster.
Okay. Yeah. Okay, great, fantastic.
Which kind of guarantees you can give to clients in terms of permanence of storage, and did you talk with insurance companies in terms of insurability?
It's exactly our interest right now, actually. This is going to be the first clients that we believe that we can have, because actually their data is valuable, and DNA can last for thousands of years without loss of information. So the goal is that for at least there have been tests according to the content, according to where we're going to store the DNA. We have solutions to make it last for long periods of time that have been already tested and that can last for thousands of years without alteration.
Okay, probably last question. Yes, thank you.
Yeah, you said it's not science fiction. The idea's been around a long time.
Yes.
Why is it so slow to come to pass? Are you raising enough money? Have you got a big enough team?
Yeah.
You know, are you going to get there before some other people?
Yes. Yes. So I'm going to be very honest on that. The reason why it's so slow, I guess, it's because people don't have the money to go for it as fast as they should. Actually, there are startups that are working on it. We're all in the process of raising right now. And the main challenge is to automatize the process. So it brings together different sectors, biology, informatics, everything. So I believe there's a lack of collaboration. Maybe we should try to collaborate in order to bring this further, because each one alone cannot do it.
I'm sorry, I cannot take any questions. We have 9 seconds left. Thank you very much for all the questions. We managed quite a few.
Thank you.
Thank you.